This question. Let cut-in voltage V gamma is equal to 0.7 volts for each diode in the circuit shown below. Some circuit is given and V gamma is given, mentioned. The voltage V output and the current ID1 are. What about the output voltage and current through the diode D1? They are asking. How do we do this? So V gamma is mentioned, means what is the equivalent circuit of the diode? The diode characteristics might be something like this. V gamma. It's like an ideal voltage source. Once the diode is in conduction, diode can be replaced by means of an ideal voltage source. We can take it. Okay. So let us have a look at the status of the diodes D1 and D2. If you see the diode D1, its anode is going to 10 volts and cathode is going towards ground potential. It looks like D1 is conducting. And D2 also, if you observe the anode of D2, it is going to 10 volts and its cathode is going towards minus 10 volts. D2 is also conducting. Assume D1 and D2 are conducting. So what is the equivalent circuit we can see? Instead of diode, I am writing it by means of an voltage source. Without that also we can write so. Here voltage source value is 0.7 volts. This is V output. Okay. With this circuit, let us have a look at the currents ID1 and ID2. If both are positive or assumption is correct, then I can finalize V output. It's not like simply finding the V output. First of all, we have to see whether our assumption is correct or not. इसके बाद देखना है आउटपुट का वैल्यू क्या है ये सब. Okay, let me assume the current through the diode D1 as ID1 and current through D2 as ID2. Yes, what about ID2? First, we can't calculate ID1 and let me take this current as I, which is equal to ID1 plus ID2. Okay, so I can write even I is equal to 10. Here what is the voltage? It is 0.7 volts. 10 minus 0.7 by 10 kilo ohm. It is equal to 0.93 milliampere. Then what about ID2? ID2 can be written like here the voltage is 0.7, or we can take right. Okay, right, if I take the loop equation, from that also we can write. Okay, just I'm writing the loop equation, otherwise it is right. If I consider this particular loop, let me take L1. What we can write, I'm just taking with polarities minus plus, minus 0.7 plus 0.7 plus ID2 into 5k minus 10 is equal to 0. See this. Minus 0.7 plus 0.7 plus ID2 into 5k minus 10 is equal to 0. Okay. Then what about ID2? It is equal to 10 by 5 kilo ohm. It is 10 milliampere. ID2 we have got and I also we have got. Then what about ID1? I is equal to ID1 plus ID2. So I value is found to be 0.93. Anyway, ID1 and ID2 are positive. ID1 plus ID2 also should be positive. It should be greater than any one of ID1 or ID2. Very simple common sense point. But here I is found to be 0.93 milliampere and ID2 is found to be 2 milliampere. Is it possible? No. Or I can write ID1 is equal to I minus ID2. It is equal to 0.93 milliampere minus 2 milliampere. I need not calculate, it is negative. ID1 and ID2 are positive as the diodes are in conduction. Their sum should be greater than any one of either of ID1 or ID2, but it is 0.93. It is not possible. Negative. It is not possible. Means our assumption is wrong. What is our assumption? D1 is off. Right? ID2 is coming positive, but this is not the exact value. It looks like ID2 is positive. That's it. But ID1 is negative. ID1 is negative means not possible means implies D1 is off. Diode D1 does not conduct. Implies ID1 is equal to 0. Next, what about we output then? Anyway, so the equivalent circuit changes this way. Instead of ID1, it is open circuit. Instead of ID2, 0.7 volts. Next 5K and minus 10 volts. It is mentioned as V output. Here it is 10 volts and 10 kilo. This is our equivalent circuit in which the entire ID2 flows in this direction. Okay, let it. For finding the output, there are two ways. We can find ID2, then V output is equal to ID2 into 5K minus 10 volts. Instead of that, I'm just taking this node equation. Let me take this is node A. So KCL at node A. Then V output minus of minus 0.7 minus 10 by 10 kilo ohm plus here V output minus of minus 0.7 minus 10 by 5K plus V output minus of minus 10 by 5K is equal to 0. That gives us V output. Okay, so here kilo cancel and 5 2's. So V output by 2 plus V output, it is 3. V output by 2 is equal to 10 minus 0.7, right? Or I am writing here minus 0.7 plus 10 by 2 minus 10. We can take like this. So further, how much do we get? Here it is 9.3 minus 20. It is 11.7 by 2. Straight away I am writing. So what is V output? It is 11.7 by 3. If you calculate it, it is found to be some 3 minus 3 point. No, it is negative sign. 3.566 something you will get it. Okay, that's it. So what we can observe from this, V output is negative, and if you take the voltage at this particular point, see, V output is found to be almost minus 3.6. So here it is found to be minus 3.6. D2 is on. What will be the voltage at this point? Minus 3.6 plus 0.7 minus 2.9. Here it will be around minus 2.9 volt. Then how is it possible for D1 to conduct? Okay, I hope you understand it. It is minus 3.6 volts approximately, for which if I add plus 0.7, it becomes minus 2.9 sorry, it's more, no, minus 3.6. Okay, correct. Here it is minus 2.9 volts. Okay. So is it possible for D1 to conduct here? No. D1 does not conduct. Okay, because its anode is at negative potential and cathode is at ground potential. We can take like this. Okay, this is the idea here. Okay, this is how we can understand. Anyway, right, these are all additional things. What did they ask in this problem? Means ID1, it is found to be 0. So, and ID1, it is found to be 0 and V output is equal to minus 3.567. So actually there is a printing mistake in the options. So here we can make 3.57 or here it is 0. Any one value we need to change. Or you can take this as 0 milliampere and option B is correct. Okay, I have made some correction in this. Right, this is the idea. Okay, this is how we can do this problem. Next, see this. Find the value of I2 in the circuit shown. I2, current through the silicon diode they are asking. It is shown like germanium and silicon diodes. Germanium, once it is on, voltage across the germanium diode is 0.2 volts, and if silicon diode is in conduction, voltage across it is 0.7 volts. Okay, what is the current through this particular silicon diode they are asking? Here, if you observe this, it looks like both silicon and germanium are in conduction. Silicon, its anode is going to 10 volts and its cathode is going to ground potential. Silicon diode is conducting. The same thing we can think of germanium diode as well. Its anode is going to 10 volts and cathode is going towards the ground. So it looks like both germanium and silicon diode are on. So I'm taking here, assume. Let me take this is D1 and this is D2. Just for our convenience sake, I'm writing D1 and D2 are on. Both are conducting. If so, what is the equivalent circuit? Voltage across germanium diode, we can write it is voltage source of value 0.3 volts and voltage across silicon diode is 0.7 volts. Plus 10 volts. This is the circuit. And coming to the currents, this current is, let me take ID1 and this current is ID2. Let me take this current as I. Okay. As it is 0.7, what is V output? Or 10 is equal to, if I take this particular loop, 10 is equal to voltage between these two terminals, it is 0.7 plus V output. I can write 10 is equal to 0.7 plus V output implies V output is equal to 9.3 volts. If that is the case, what about I? I is equal to V output by 1K. It is 9.3 milliampere. We got I as well. Then ID1 and ID2. We can find ID1. How? It is mentioned 3K. The voltage between these two terminals is 0.7. and here it is already 0.3, then what is ID2 into 3K? It should be equal to 0.7 volts, or ID1 plus into 3 kilo ohm plus 0.3 or 0.2, sorry friends, it is 0.2 plus 0.2 is equal to 0.7. So ID1 is equal to 5 by 0.5 by 3 kilo ohm, or 1 by 6 milliampere, or I can write 0.167 milliampere. ID1 is 0.167 milliampere and I is 9.3 milliampere. So what is I2 or ID2? Right? ID2 is equal to ID1 plus ID2 is equal to 9.3 milliampere. So ID2 is equal to I minus ID1, or I2 or ID2, doesn't matter. Its value is equal to I. It is 9.3 milliampere minus 0.167 milliampere. So how much do we get? It is 9.133 milliampere. So option C is correct. Okay, that's it. This is how we can do this problem. The resistors are chosen in such a way that there is no issue with in our assumption. I started with an assumption of D1 and D2 are on. Okay. By changing either 3K or 1 kilo ohm resistor, right? Instead of 3K, I can take uh, another smaller value so that ID1 increases. Then ID1 plus ID2, here anyway V output is fixed 9.3 and I is 9.3 milliampere. So by reducing the value of 3K, I can increase ID1, and such that ID1 plus ID2 may exceed 9.3 milliampere. Possible. Okay. In that case, our assumption will be failed. Right? It all depends upon the data given. Or even instead of 1K, if it is taken 10 kilo ohm, then ID1 plus ID2 becomes 0.93 milliampere. Okay, or 10K, or well, anyway, it all depends. Then also it's possible for both D1 and D2 to conduct. Anyway, you understood the concept. By changing the resistor values, we can see the change in currents. Accordingly, the status of the diode may change. But the procedure is not changing. What you need to observe is the procedure. Okay, next. See this problem. For the circuit shown below, the cut-in voltage of diodes is V gamma is equal to 0.7 volts. What are the values of V and I? Okay. If you look at this question, what is happening? Its anode is connected to 1 volt and its cathode is connected to ground. It looks like diode D1 is on. And look at the diode D2. Its anode is going to 3 volts and cathode is going towards ground. It looks like D2 is also connected. It looks like both D1 or D2 are connected. Okay. First of all, is it possible? Never. Not. Why? See, suppose D1 is on, voltage across D1 will be 0.7 volt plus minus. It is 1 volt. And suppose D2 is on, voltage across D2 is also 0.7 volts and it is 3 volts. Both cathodes are shorted. It is going to 2 kilo. Then what will be the voltage here? 1 is equal to, right, or here V output. It is 1 minus 0.7. The voltage at this particular point with respect to D1, if you see, With respect to D1, if you observe, so 1 minus 0.7, here it is 0.3 volts. Whereas with respect to D2, if we observe, it is 3 minus 0.7, it is 2.3 volts. Is it possible? Not. At the same node, with respect, right, the node at the same node, you can see with respect to D1, it is looking like 0.3, with respect to D2, it is looking like 2.3. Which is correct? Okay, so here what happens is D1 is off and D2 is on. Okay, because if D1 is on, here 0.3 volts comes. For 0.3 volts, what happens to D2? Its a cathode is at 0.3 volts and anode is at 3 volts. D2 should also conduct. If D2 also conducts, voltage at this point should be 2.3 volts. But 0.3 and 2.3 volts cannot appear at the same node simultaneously. So absolutely my assumption is wrong. Then the correct assumption is D2 is on and D1 is off. See here, if D2 is on, here it is 3, it is 0.7, it is 2.3. Then look at D1, its a cathode of D1 is at 2.3 volts and its anode is at 1 volt. So D1 is off. Cathode of D1 is at higher potential compared to its anode, and hence D1 is off. D2 anyway remains in on state. This is the idea here. So it's not like simply taking both diodes are conductive. It is not possible for both the diodes. And why I am not calculating the currents in this circuit? How can I calculate? Not possible. Without calculating the currents ID1 and ID2, I am solving this problem. The reason is we can't calculate here. Earlier problems we can, right? When there is a scope, we will calculate. Here it is not possible to calculate the currents ID1 and ID2. Okay, so ID2 का वैल्यू हम कैलकुलेट कर सकते हैं, right? But ID1 is anyway 0. So here D1 will be off and D2 will be on, and the entire ID2 flows in this direction, and ID1 will be equal to 0. And what about ID2 then? What did they ask? V and I. What is V? V means voltage at this point with respect to ground. This is our V. V is equal to 2.3 volts. And I means I is equal to ID2 is equal to 2.3 volts by 2K. It is 1.15 milliamperes. Option A is correct. Very, very simple. Okay. So this is how we can solve this problem. Here, for the first time, without calculating ID1 and ID2, I have made a conclusion that D1 is off and D2 is on, even though the anodes of both the diodes are connected to some positive potential. Okay, this is how we can do this. And one more thing, here, some observation. When cathodes are at the same potential, both cathodes are shorted, then the diode with higher anode voltage only conducts. One simple point I would like to mention here, I have a diode like this. When anode voltage is greater than cathode voltage, the diode conducts. VA should be greater than VC. Anyway, both cathodes are at the same potential. Then which anode is at higher potential? The anode of D2 is at higher potential. That only will conduct. That's it. A very, very simple. So let me write a note. When cathodes of two or more diodes are at the same potential or same voltage, then the diode with highest anode voltage only conducts and the remaining diodes will be off. This is one important point we can see. So all cathodes are at the same potential. Here as an example we took one diode, two diodes. They need not be two. You can connect n number of diodes. Of course, right? The current through the diodes, should not exceed the maximum allowable current through the diode. We may connect n number of diodes, but and all the cathodes are at the same potential. Then the diode with highest anode voltage only conducts, and the remaining will be simply off. That's it. So that is the observation. Here I am not calculating current through the each diode. Okay, instead of that, straight away I am doing it like this. See this problem. For the circuit shown below, values of V and I are, what about the values of V and I? Okay, look at the diode D1. Its anode is going to 1 volt, but its cathode is going to 5. So is it possible for D1 to conduct? Even though the cathodes are at the same potential, it is not like simply we can conclude that the anode of D2 is at higher voltage, so D2 will conduct. It is not so. First of all, we have to look at the basic condition. See, in the previous problem, if you see, cathodes are at the same potential and both are going towards the ground, and the diode with highest anode voltage is conducting. But in this problem, the cathodes are at the same potential, but that cathode is going towards 5 volts, which is greater than the anode voltage of either D1 or D2. Okay, anode of D1 is 1 volt at 1 volt, and anode of D2 is at 3 volts. Both the anode voltages are less than the power supply voltage, 5 volts. So no diode conducts in this example. If so, what is the equivalent circuit? One volt, 3 volt, 10K, 5 volt. I is the current flowing and V is the voltage. Is there any current possible in this circuit? Because why I am doing this problem immediately means here I made a statement. When cathodes are of 2 or more diodes are at the same voltage, then the diode with highest anode voltage only conducts. Of course, it's possible if and only if there is a scope for the diode to conduct. Okay, but here there is no scope for any of the diodes to conduct because both cathodes are going towards higher potential compared to their anodes, even though cathodes of both the diodes are at the same voltage. Okay, I is 0, then what about V? V is equal to 5 volts, or I can write 5 volts is equal to, if I take this particular loop, it is I into 10K plus V, where I is 0 implies V is equal to 5 volts. So 5 volts comma 0 milliamperes. Option A is correct. See how simple the problem is. Okay. Again, 3 diodes are given. I told you it may be 2 or more than 2. Doesn't matter. Look at the anode voltages and cathode voltages. All the cathodes are shorted. Cathodes are going towards ground. It looks like all the 3 are conducting, but it is not possible for all the 3 together to conduct simultaneously. What we have to see, the diode with the highest anode voltage only conducts and the remaining diodes will be off. Okay, here they have not mentioned anything about V gamma and all, so assume ideal diodes. Then if diode, let me take D1, D2, D3. If D1 is on, voltage, it acts as short circuit and voltage here is 3 volts. Then is it possible for D2 to conduct? No, its cathode is going to 3 volts and anode is going to 2 volts. D2 does not conduct. Same scenario with D3 as well. Its cathode is at 3 volts and anode is connected to 1 volt. Okay. So D1 on and D2, D3 are off. Then what is the equivalent circuit? Three volts, 2 volts, 1 volt. We output and this current I. I is equal to ID1. This current is ID1. We output, it is equal to 3 volts. It is 1K. I is equal to 3 by 1K, 3 milliampere. 3 volts, 3 milliampere or 3 milliampere. I and V. Okay. This is the idea. Find the value of V0 in the circuit shown in figure. Again, the same thing. Cathodes of all the diodes are at the same potential. And look at cathodes are all the 3 cathodes are shorted. And here 2 volts reference voltage is let it be. Coming to D1, its anode is connected to 1 volt and the cathode is going towards 2. It is not possible for D3 to conduct. What about D2? Its anode is connected to 5 and its cathode is connected to 2 volts. It looks like D2 is also off. And D3, sorry, D1. Its anode is at 1.5 volt and cathode is going towards 2 volts. Sorry, D1 is also off. Then D2 is on. Okay. Because once D2 is on, it acts as short circuit as it is ideal diode. Here 5 volts can be seen. Then means voltage along this line is 5.